In the vast silence of the night sky, when we lift our gaze beyond the veil of stars, a haunting question arises. Did nothing exist before the universe? It sounds simple, almost childlike in its phrasing, yet hidden within it is a labyrinth of paradoxes, an intellectual abyss where physics, philosophy, and human imagination collide. For how can nothing be spoken of if to define it already transforms it into something? And if the universe had a beginning, what, if anything, awaited before its birth? To approach this mystery, we must first confront the limits of our intuition. We live in a world where every event seems to have a cause, every object a prior state, every story a beginning. Our minds instinctively trace backwards. Rivers flow from springs, trees sprout from seeds. Children are born of parents. So too, we ask, what was the parent of the cosmos? Did time itself have a seed? Or was the origin of everything truly an emergence from nothingness, a spontaneous birth without precedent? Modern cosmology was not always prepared to grapple with such unsettling ideas. For much of human history, the universe was assumed eternal and unchanging. Ancient Greek philosophers like Aristotle argued that the cosmos had no beginning, it simply always was. In India, cyclical cosmologies envisioned endless cycles of creation and destruction, with universes blossoming and collapsing like breathing lungs of eternity. Even when European astronomy advanced under Copernicus, Galileo, and Newton, the prevailing assumption remained. Space and time stretched endlessly in both directions, a stage without origin upon which the cosmic drama unfolded. But the 20th century broke that illusion. With Einstein's general relativity, space and time themselves became dynamic, woven into the fabric of a malleable space-time. Galaxies were not static ornaments, but travelers in a flowing cosmic river. And in the 1920s, Edwin Hubble revealed that this river was expanding, the galaxies racing apart, their light stretched into crimson signatures of retreat. If the universe was expanding, logic dictated that in the past it had been smaller, denser, hotter. Push far enough back, and one arrives at a singular origin, a moment when everything we see condensed into an inconceivable point. This was the birth of what came to be called the Big Bang, a term first uttered dismissively by Fred Hoyle, who preferred an eternal, steady-state cosmos. Yet the name endured, and with it came a new frontier of imagination. If there was a beginning, what came before? At first, cosmologists hesitated to ask. The equations of relativity led to infinities at the moment of the Big Bang, a signal that our theories break down. To speak of before seemed meaningless, like asking what lies north of the North Pole. For if time itself began with the Big Bang, then the word before dissolves into nonsense. There was no before, just as there is no place north once you reach Earth's axis. And yet, the human mind resists such closure. We hunger for explanation. If time began, what mechanism ignited it? If nothing preceded, how did something arise? Our language falters, but our curiosity does not. Scientists began probing this limit with bold ideas. Quantum mechanics suggested that emptiness is never truly empty. Even in a vacuum, particles flicker in and out of existence, ghostly apparitions born of uncertainty. Could the universe itself have emerged from such quantum fluctuations? Physicist Edward Tryon once proposed that the cosmos was simply a gigantic quantum event, the ultimate free lunch, where energy borrowed itself from the void, balanced precisely so that the total sum was zero. Others envisioned the Big Bang not as a singular beginning, but as a transition, a balance from a prior universe. In cyclical cosmologies, universes may endlessly collapse and rebound, like a heartbeat without end. String theory introduced the idea of colliding higher-dimensional membranes, where our universe is just one bubble born of a cosmic clash. The inflationary model, pioneered by Alan Guth and André Linde, painted a picture of exponential expansion triggered by a mysterious field spawning countless pocket universes in an endless multiverse. But each of these attempts circles back to the same haunting core. What is nothing? Is it the quantum vacuum, a seething froth of fluctuations? Is it absolute non-existence, devoid of space, time, and law? Or is nothing simply a word we use to mark the frontier of our ignorance, a placeholder until deeper physics can illuminate the shadows? Imagine for a moment stripping away everything: galaxies, stars, atoms, even the space between atoms. Remove the stage of space-time itself. Remove the laws of physics that govern the dance. What remains? If the answer is nothing, then it is unlike anything we can conceive, for our very conception depends on existence. Yet perhaps it is precisely from this inconceivable nothingness that the miracle of being emerged. The drama of this question is not confined to chalkboards and equations. It reaches into our deepest myths and spiritual yearnings. Nearly every culture has wrestled with the mystery of origins, from creation rising out of cosmic eggs to worlds crafted from chaos by divine hands. Science, for all its rigor, has joined this ancient quest, armed not with myth, but with mathematics and telescopes that peer across billions of years. And so we find ourselves poised at the edge of comprehension, staring into the abyss where the universe was born. To say, once there was nothing, is to step into paradox. To say, something always was, is no less bewildering. Both choices defy the comforts of ordinary logic. Yet within this tension lies the story of everything: the galaxies overhead, the earth beneath our feet, and the mind within us daring to ask the impossible. And so our journey begins, into the physics of creation, the history of discovery, and the profound enigma that is the origin of existence itself. If we attempt to trace the universe backward, as though rewinding a film reel of cosmic history, the images rush toward greater density, greater heat, until at last they blur into the unseeable blaze of the first instant. The Big Bang itself is hidden from us, obscured by physics not yet fully grasped. What we can see, however, is the afterglow, a faint, pervasive radiation that fills all of space, discovered in 1965 by Arno Penzias and Robert Wilson. They were radio astronomers, tuning their antenna in New Jersey when they encountered a persistent hiss, a background signal that could not be removed, not by cleaning pigeon droppings from the equipment, nor by adjusting the electronics. This hiss was no local interference. It was the echo of the universe's birth. The cosmic microwave background, as it became known, is the oldest light we can observe, emitted when the universe was merely 380,000 years old. In its faint irregularities lie the seeds of galaxies, the primordial imprints of structure. It is a photograph of creation itself, proof that our universe once existed in a hot, dense, and astonishingly uniform state. Yet even this ancient light is not a glimpse of the beginning. It is the aftermath, the embers, not the flame. To peer deeper still, beyond the first moments, we must turn not to telescopes, but to the realm of theory, where mathematics strains to describe conditions no experiment can replicate. In those first fractions of a second, the universe was smaller than an atom, hotter than the core of any star, a realm where the familiar laws of nature dissolve. Gravity, electromagnetism, nuclear forces, all were fused in ways we cannot yet describe. Our equations collapse into infinities, as though nature is warning us that we have asked a question too soon. At this frontier, the need for a quantum theory of gravity emerges, a framework that unites the vast with the infinitesimal. Physicists pursue this elusive theory through string theory, loop quantum gravity, and other ambitious constructions. None are yet complete, but all hold the promise of revealing what, if anything, came before the Big Bang. One possibility is that time itself had a beginning, a boundary beyond which the very notion of before evaporates. This view was crystallized in the work of Stephen Hawking and Roger Penrose in the 1970s, when they proved theorems showing that under general relativity, a universe that expands as ours does must originate in a singularity, a point where density and curvature become infinite. To many, this seemed to seal the question. The universe simply began. There was no prior, no before, only the sudden birth of space-time itself. But even Hawking himself later tempered this view, suggesting instead a softer origin. In his no-boundary proposal, the beginning of the universe could be likened not to a sharp edge, but to a smooth curve, where time gradually transforms into space, eliminating the need for a singular starting point. If so, the question, what happened before the Big Bang, may be ill-posed, like asking what lies south of the South Pole. And yet, not all physicists are content with such an answer. Some suggest that the singularity theorems point not to the impossibility of a prior universe, but to the limitations of our theories. Perhaps the Big Bang was not the absolute beginning, but a transition, a doorway from one state to another. Inflationary cosmology provides a tantalizing framework for such ideas. Proposed by Alan Guth in 1980, inflation describes a period of ultra-rapid expansion in the universe's earliest instance, when space itself ballooned faster than the speed of light. This sudden stretching explains why the cosmos today appears so smooth and uniform across vast distances, and why its geometry seems nearly flat. But inflation carries further implications. If space can inflate once, perhaps it can inflate again, eternally, in different regions. In this picture, our universe may be one bubble in an endless froth, a multiverse where beginnings happen ceaselessly, each bubble with its own physics, its own stars, its own potential for life. But this too raises the same riddle. If there is an eternal multiverse, what underpins it? From what primordial condition do these bubbles arise? Even if universes are infinite, does that infinity not still require a framework, a set of rules, a stage upon which eternity itself is possible? And if that stage exists, can we truly call it nothing? Here lies a deeper tension between physics and philosophy. In physics, nothing often means the quantum vacuum, a state devoid of particles, but alive with fluctuations. The Heisenberg uncertainty principle ensures that even in perfect emptiness, energy cannot rest. Virtual particles appear and vanish, space-time jitters with possibility. From such a seething vacuum, some physicists argue, a universe could erupt spontaneously, its total energy balanced to zero by the tension between matter and gravity. This is the universe from nothing, suggested by Tryon and later popularized by Lawrence Krauss. But critics are quick to respond. A quantum vacuum is not nothing. It is a something, a fabric of laws, a space in which fluctuations occur, a set of mathematical rules that permit existence. True nothingness, the absolute absence of being, has no canvas for physics to act upon. It has no equations, no time, no chance. How could then give rise to everything? Perhaps the phrase "universe from nothing" is a misnomer, more a reflection of our yearning for simplicity than a literal description. And yet consider the alternative. If nothing cannot yield something, then perhaps there has always been something. not necessarily our universe, but some form of reality, eternal and self-sustaining. The philosopher Leibniz posed the haunting question, why is there something rather than nothing? To answer with, there has always been something, may sound unsatisfying, but it may also be the most natural truth. After all, nothingness may be the more unstable state, while existence, once it begins, perpetuates without end. This is not a new struggle. Centuries earlier, theologians and mystics grappled with similar paradoxes, though couched in the language of creation and divinity. Augustine of Hippo, in the 4th century, wrestled with the nature of time itself, declaring that time was created along with the world. There was no before for God to act within. In Hindu cosmologies, universes bloom and perish in vast cycles, their origins unneeded because the process is endless. In Buddhism, the question of beginnings is often set aside as unanswerable, a distraction from the deeper matter of suffering and liberation. Science, however, cannot turn away. Our telescopes probe deeper. Our accelerators smash particles into echoes of primal fire. Our mathematics stretches toward the horizon of the unthinkable. And though we may never stand at the precipice of absolute nothingness, we can illuminate the shadows around it. Each discovery reveals that what we once thought empty is filled with hidden depths. Atoms revealed subatomic particles, which in turn revealed quarks, gluons, and fields. Vacuums revealed fluctuations. Fluctuations revealed dark energy. Perhaps nothingness itself will, in time, reveal a structure we cannot yet conceive. And so the question persists, pressing upon us like the faint hiss of cosmic radiation. Did nothing exist before the universe, or is nothing merely the name we give to what we have not yet understood? As our understanding of the cosmos has deepened, the concept of nothingness has grown ever more elusive, shifting like a horizon that recedes the closer we approach. The deeper physicists peer into the subatomic world, the more they discover that emptiness is not empty at all, but a stage alive with unseen forces. In the quantum realm, what we call vacuum is not absence but presence, a simmering field where possibilities hover before bursting into reality. This paradox is perhaps the first clue that our intuition about nothingness may be profoundly misleading. Imagine, for a moment, the early 20th century, when the atom was thought to be the ultimate indivisible unit. To speak of nothing meant simply the absence of atoms, of matter. But then came quantum mechanics, and suddenly the void revealed itself as a restless ocean. Werner Heisenberg's uncertainty principle declared that energy cannot be pinned down to exact stillness. In every region of space, no matter how empty, virtual particles flicker into being and annihilate, their ghostly signatures hinted at in experiments. This is not speculation alone. Phenomena like the Casimir effect, where plates in a vacuum experience measurable forces, testify to the reality of this invisible activity. The vacuum, it seems, has weight, energy, and consequence. And if the vacuum itself possesses energy, then it may have shaped the entire history of the universe. Cosmologists call this dark energy, a mysterious force driving the acceleration of cosmic expansion. It is everywhere, woven into the fabric of space. Yet its origin remains obscure. Some argue it is the energy of the vacuum itself, the baseline hum of existence. If so, then what we casually call nothing is in fact the greatest something of all, the engine that pushes galaxies apart, the dominant constituent of the cosmos. But if the void is filled with such vitality, can we ever reach the true nothingness our minds imagine? A condition stripped not only of matter and energy, but of fields, forces, laws, of even the stage of space-time itself? This is the deeper frontier, one that physics struggles to approach. For to speak of absolute nothing is to imagine not just an empty room, but no room at all, no dimensions, no time in which events could occur. Our equations break down at this threshold because equations presuppose a context in which they operate. To ask them to describe nothingness is to ask a melody to play without sound. And yet, even in this abyss of thought, new theories venture boldly. Some cosmologists propose that the universe could be self-contained, its laws arising with it, requiring no external cause. Others imagine that space-time is emergent, like a mirage conjured by deeper structures we cannot yet see. If space-time itself is emergent, then perhaps the origin of the universe was not an event in time, but the very emergence of time itself, a transition from timeless potential into flowing moments. This notion of emergence recalls the discoveries of condensed matter physics, where collective behavior gives rise to properties no single particle possesses. Just as temperature and pressure emerge from countless molecules in motion, so too might time and space arise from some more fundamental pre-geometry. In such a view, asking what came before the universe might be like asking what temperature was before there were molecules. The question dissolves because the property did not yet exist. And yet, for all the elegance of these ideas, they cannot silence the haunting question: why is there anything at all? Why does the fabric from which space-time emerges exist rather than nothing? Here, science collides with philosophy, and both with mystery. Some thinkers suggest that nothing is inherently unstable, that given eternity, existence must eventually blossom from its void. Others propose that existence is necessary, that nothingness is not a viable option. Still others contend that we may never know, that the origin of everything lies beyond the reach of reason itself. History reminds us that such humility is wise. Again and again, humanity has mistaken the frontier of knowledge for the ultimate limit. Once the Milky Way was the universe entire. Once atoms were indivisible. Once space was absolute and unchanging. Each time, discovery shattered the illusion of finality. Perhaps our current struggle with nothing is another such illusion, destined to be redefined by revelations still to come. Consider the debates that raged in the mid-20th century, when the Big Bang itself was controversial. Many scientists resisted the idea of a beginning. An eternal universe felt safer, more in line with the uniformity of physical law. Werner Hoyle's steady-state theory argued that as galaxies moved apart, new matter was continuously created, filling the gaps, preserving eternity. This vision was elegant and comforting, until the discovery of the cosmic microwave background rendered it untenable. The universe, it seemed, did have a fiery birth, and yet Hoyle's resistance captures something profound. Beginnings are unsettling. They force us to confront the possibility that the universe itself is contingent, that it could have been otherwise or not at all. This unease continues to haunt the edges of cosmology. If the Big Bang was a beginning, then we long to know what preceded it. If it was a transition, then we seek the prior state. If it was a fluctuation from a vacuum, then we ask what defines that vacuum. Every answer unfolds into another question, each layer of explanation revealing new depths. Perhaps the pursuit itself is the point, that the cosmos forever lures us deeper, never permitting final rest. But if we allow imagination to stretch, another picture emerges, strange and wondrous: the multiverse. Inflationary theory suggests that our universe may be only one bubble among countless others, each birthed by quantum fluctuations in an eternally inflating space. In this vision, there was no single beginning, but endless beginnings, no unique universe, but a vast ensemble. Some bubbles collapse in instants, others expand into realms of galaxies and stars. Each may possess its own laws, its own physics, its own notion of reality. If so, then the question, why is there something rather than nothing, transforms. For in an eternal multiverse, nothing never exists. There is always some pocket of being, some patch of reality. Existence is not a fragile accident, but an eternal backdrop. Yet such ideas remain speculative, beyond the reach of current observation. For now they live in the realm of hypothesis, awaiting the subtle fingerprints they might leave on our universe. And so we stand at a crossroads of thought, between physics and philosophy, certainty and speculation, knowledge and wonder. The night sky above, glittering with stars, is both a window into the past and a mirror for our deepest questions. To gaze into it is to feel the pull of infinity and the silence of nothingness beyond it. Did nothing exist before the universe? Or is nothing itself an illusion, a word with no true referent in the story of reality? When we consider the possibility of nothingness, we are inevitably confronted with the fragility of time itself. Time as we experience it feels so absolute, so unbroken, an arrow stretching from the past through the present into the future. Yet modern physics paints a subtler, stranger picture. Time is not an independent stage upon which events play out. It is interwoven with space, molded by mass and energy. Einstein's general relativity showed us that clocks tick differently, depending on where they are, how fast they move, how deeply they sit in gravity's embrace. Time is elastic, not fixed, and this malleability suggests a deeper truth. Perhaps time itself did not exist until the universe gave it form. This idea unsettles us because we are prisoners of temporal intuition. To imagine a beginning of time is to stretch our minds into unfamiliar territory. We instinctively ask what came before, but if time began with the universe, then before is a meaningless word. Augustine sensed this more than a millennium ago, writing that God did not create the world in time, but with time. Modern cosmology echoes this sentiment. If the Big Bang was the birth of time, then the universe has no prior state in a temporal sense. The beginning is not an event within time, but the dawn of time itself. Still, our minds resist. We yearn to know what lay beyond the horizon of the Big Bang. To appease this hunger, scientists have proposed bold visions. One is the idea of a cosmic bounce, a cycle in which universes collapse and rebound endlessly. In this picture, time stretches infinitely in both directions. Our Big Bang was not the beginning, but the latest in an eternal sequence. Such models draw inspiration from ancient cosmologies, where cycles of creation and destruction echo the rhythms of nature. The turning of seasons, the life and death of stars, the rise and fall of civilizations. Loop quantum cosmology, an offshoot of loop quantum gravity, provides a mathematical glimpse of how such a bounce might occur. By quantizing space-time itself, it suggests that the singularity of the Big Bang could be replaced by a minimum volume, a point of maximum compression after which expansion resumes. If true, then the universe did not emerge from nothing, but from a prior contraction, a phoenix rising from its own ashes. Yet whether this vision is reality or elegant speculation remains unresolved. Another possibility lies in the enigmatic field of string theory. In some versions, our universe exists as a three-dimensional membrane floating within higher dimensional space. Collisions between such membranes could spark big bangs, birthing new universes with each cosmic impact. In this picture, our own universe's beginning was not the origin of everything, but one event in a grander, multidimensional stage. Here the word nothing is again transformed. What seemed like a void may be brimming with unseen dimensions, hidden surfaces colliding beyond our perception. Even inflationary theory pushes us toward the multiverse. If inflation is eternal, then universes are continually spawned, each with its own birth moment, each expanding into its own cosmos. In this landscape, nothing becomes rare. There is always something, somewhere. The true question shifts, not why is there something rather than nothing, but why does this universe exist among all possible ones? Yet even as science offers these grand vistas, it also forces us to confront the limits of knowledge. Observationally, we can only see as far as light has traveled since the Big Bang, about 13.8 billion years. Beyond that horizon, we cannot peer. The earliest instants are hidden from us, shrouded in energies we cannot replicate in laboratories, masked by the opacity of the young cosmos. What happened at the very beginning, or before, if before has meaning, may be forever beyond our reach. But this limitation does not quell the mystery, it deepens it. The silence of the unknown is not an ending, but an invitation, a beckoning toward deeper thought. Perhaps we will uncover subtle clues, patterns in the cosmic microwave background, signatures in the distribution of galaxies that hint at what lies beyond our horizon. Already, measurements of primordial gravitational waves, if they can be detected, promise to open a new window onto the universe's first heartbeat. Through such whispers, we may catch echoes of creation, faint traces of what was once thought unreachable. Yet, no matter how far our instruments extend, we may always face the abyss of ultimate origins. For even if we trace the universe to a prior state, we must still ask why that state and not nothing? Why those laws of physics and not others? Each explanation shifts the question but never abolishes it. The enigma of nothingness stalks us, always a step ahead, always deeper than our answers. Perhaps this is the very nature of the question, that it is not one we solve, but one we live with. The search for origins is a mirror of our own condition. Finite beings gazing into infinity, trying to anchor ourselves in a cosmos that offers no easy beginning. And in that search lies a peculiar beauty. For it is not certainty that drives us, but wonder, the restless urge to illuminate the darkness. The physicist John Archibald Wheeler once remarked, "Nothing is more important about the quantum principle than this, that it destroys the concept of the world as sitting out there. The universe will never again be the same, because we are compelled to say that what we call reality arises in the last analysis from the posing of yes-no questions. In other words, reality itself may not exist as a passive given. It may arise through interaction, through questions asked and answered. If so, then the line between nothing and something is blurrier than we imagine. Perhaps nothingness is not an absence, but a potential, a silence that waits to be awakened by the act of existence. To imagine this is to stand at the threshold of awe, where physics and philosophy entwine. The cosmos is not merely a stage for matter and energy, but a story of emergence, of being arising from mystery. Did nothing exist before the universe? Or is nothingness itself an illusion, a mirage born of human longing for origin and simplicity? There is a curious irony in our confrontation with nothingness. The more rigorously we attempt to define it, the more it slips through our grasp, transforming into something else entirely. Each time we declare the void empty, deeper investigation reveals hidden layers. First atoms, then particles, then fields, then the restless hum of quantum fluctuations. At each stage, what was once thought to be nothing has proven to be a fertile ground of activity, a canvas already painted with invisible strokes. Perhaps true nothing, if it exists at all, is beyond not only our observations, but our very capacity to conceive. And yet, science has never been deterred by difficulty. The frontier of cosmology is littered with bold attempts to sketch the contours of the unthinkable. Some physicists, taking cues from quantum mechanics, suggest that the origin of the universe can be understood as a fluctuation from a state of zero energy. In this view, the sum of all existence might balance perfectly, the positive energy of matter and radiation offset by the negative energy of gravity. If the universe's total is truly zero, then its emergence could require no external cause, no prior seed, only the spontaneous blossoming of balance. But here again, words deceive us. To call such a fluctuation an emergence from nothing stretches language beyond recognition. The quantum vacuum is not nothing. It is a structured state, governed by equations, bounded by symmetries, teeming with possibility. The laws of physics themselves become the silent stage. If they existed before the universe, then they are not nothing, but a profound something, a set of eternal truths inscribed into the very fabric of reality. If they arose with the universe, then their very existence cries out for explanation. Why these laws and not others? This tension between law and void haunts the field. One of the most famous attempts to confront it was Stephen Hawking's claim that the universe could arise from nothing through the operation of physical laws, particularly quantum gravity. But critics have noted that such reasoning assumes the prior existence of mathematics and law itself. Can equations exist without a universe to inhabit? Is mathematics discovered or invented? These questions blur the line between physics and philosophy, pressing us to ask whether nothing can ever be separated from the frameworks we use to think about it. And in the midst of this struggle, we must also reckon with the limits of human language. Words like before, beginning, origin carry intuitive meanings born of daily life, meanings that crumble in the face of cosmic scales. To say the universe had a beginning conjures images of fireworks, of clocks striking midnight. But the birth of space-time is not an event within time, it is the inauguration of time itself. Our metaphors betray us, dragging terrestrial images into realms where they no longer fit. Perhaps the truest thing we can say about nothingness is that it is not what we think it is. Still, the allure of beginnings is irresistible. Across cultures and centuries, humanity has woven myths of creation, each grappling with the same enigma in its own tongue. The Greeks spoke of chaos, the yawning void from which the cosmos emerged. In Norse legend, the gaping nothingness of Ginnungagap birthed fire and ice, whose union gave rise to worlds. In ancient Egypt, the primeval waters of Noon held the potential of all creation. Again and again we find the pattern, a nothingness that is not empty, but brimming with latent possibility, a womb rather than a void. Even in myth, true nothing is elusive. It is always, in some sense, a something. Modern science, though distinct from myth, cannot escape a similar pattern. The Big Bang Theory tells us that the universe expanded from an unimaginably dense, hot state. But it does not tell us why that state existed, or what, if anything, preceded it. Inflationary theory expands the canvas, suggesting an eternal backdrop from which universes continually sprout. String theory and loop quantum gravity offer glimpses of deeper structures that may underlie space-time itself. Yet each of these, in their own way, replaces nothingness with something, be it a vacuum, a cycle, a field, or a geometry. Perhaps the very act of asking about nothing betrays a hidden assumption that nothing is a legitimate possibility. But what if it is not? What if reality in some form must exist, that non-existence is simply not a coherent state? Some philosophers have argued that nothing is unstable, that existence is the default, while nothingness is the fragile, impossible alternative. From this perspective, the real puzzle is not why there is something rather than nothing, but why we ever imagined nothing could be at all. Still, we return to the silence of the night sky, and the question rises again. The cosmic microwave background whispers of a fiery origin. Galaxies recede into the dark, tracing back to a singular moment. Time stretches, but it points toward a horizon beyond which we cannot see. Beyond that veil was there emptiness, a prior universe, a higher dimensional stage, or simply nothing, absolute, inconceivable, unyielding. The drama of this question is not confined to ivory towers or observatories. It speaks to the deepest currents of human existence. To know whether there was nothing before the universe is to know something about our place in the grand scheme, whether we are actors in a transient bubble of being or participants in an eternal cycle of renewal. It is to ask whether existence itself is fragile, contingent, a brief spark in the dark, or whether it is eternal, woven into the very structure of reality. And so the inquiry continues. Each experiment, each telescope, each equation is a torch we raise against the shadows, knowing full well that the shadows may never entirely lift. The question may remain forever, a horizon that recedes as we approach. But perhaps that is the essence of the human condition, to chase answers not because they are guaranteed, but because the pursuit itself is what gives meaning.
The question of nothingness, however, is not only a cosmic riddle, but also a profoundly personal one. For in asking whether nothing existed before the universe, we are, in some way, also asking whether our own existence is necessary or accidental. We are asking whether the cosmos could have been otherwise or not at all. This question has haunted philosophers for centuries, long before telescopes revealed the galaxies or physics traced the history of time. Leibniz, in the 17th century, posed it with disarming clarity. Why is there something rather than nothing? It was, he believed, the most fundamental of all questions. For if nothing is possible, then the existence of something demands explanation. If nothing is not possible, then reality is in some sense necessary, inevitable. But how could we ever prove such inevitability? The dilemma has never been resolved, and in the centuries since, science has transformed the context, but not the weight of the question. We now speak not of God or metaphysical necessity, but of quantum fluctuations and cosmological models. Yet the unease remains the same. Why is there anything at all? As physics advanced through the 20th century, the temptation grew to answer Leibniz with mathematics. The equations of relativity, quantum mechanics, and thermodynamics seemed to offer a language for ultimate truth. Perhaps, some thought, the universe is simply the expression of mathematical law, and those laws exist necessarily, timelessly. Max Tegmark even proposed that the universe is mathematics, that existence is nothing more than structures realized in the abstract realm of numbers. If so, then nothingness may be impossible, for mathematics itself cannot not exist. But such claims provoke resistance, for mathematics, as abstract as it is, seems to demand a mind to hold it, a structure to instantiate it. Can equations exist in a void without space-time, without thought, without context? Are they eternal truths waiting to be realized, or tools invented by human minds to map reality? If the latter, then invoking them as the foundation of being risks circularity.
If the former, then we must accept a universe in which mathematics precedes matter, a Platonic cosmos where numbers themselves are primordial. Meanwhile, physicists pursue the puzzle in more empirical terms. Theories of inflation suggest that universes can sprout endlessly, each a bubble formed in the froth of a larger inflating space. The multiverse thus emerges as a natural consequence of mathematics already accepted in cosmology. And yet, the multiverse does not erase the question, it amplifies it. For why should there be an inflating field at all? Why should there be an eternal backdrop from which bubbles endlessly arise? The presence of infinite universes does not abolish the specter of nothing, it merely sets it further away. Some physicists, searching for sharper tools, have turned to the language of quantum cosmology. In such models, the universe can be described by a wave function, an all-encompassing mathematical object that contains every possible history, every potential state. The universe may not have a single origin, but a superposition of origins, paths through which it could have emerged. In this framework, nothingness is again elusive, for even the absence of classical time and space does not prevent the existence of a quantum state, a realm of probabilities rather than events. Stephen Hawking and James Hartley's no-boundary proposal is one of the most daring expressions of this. They suggested that in the earliest stages of the universe, time as we know it dissolves into a purely spatial dimension, erasing the singularity. The universe has no sharp beginning, no edge from which it sprang. Instead, it is finite but unbounded, like the surface of a sphere. Just as one cannot fall off the earth by walking north, one cannot ask what happened before the universe. The question has no anchor. The cosmos simply is, self-contained, requiring nothing beyond itself. And yet, even this elegant picture raises further doubts. If the universe is self-contained, does that mean it is necessary or merely possible? Could there have been no universe at all? Could there have been different laws, different constants, a different reality entirely? These questions cannot be dismissed, for our own universe seems finely tuned. The strength of gravity, the charge of the electron, the balance of nuclear forces all lie within narrow ranges that permit stars, planets, and life. Alter them slightly, and the cosmos might collapse or drift barren. This fine-tuning has led some to argue for the multiverse, where countless variations exist and we simply inhabit one in which life is possible. Others see in it the echo of purpose or design, though science resists such interpretations. Still, the fine-tuning problem lingers, a reminder that our universe is not only something, but a very specific something. Thus we arrive again at the haunting thought. Perhaps nothingness is less strange than the precise something we inhabit. If universes are possible in infinite variety, then why this one? Why these laws? Why these conditions? To speak of nothing is to confront not only the absence of being, but the overwhelming contingency of what is. In this way, the question of nothingness is also a question of identity. For we ourselves are the products of these laws, these conditions, these cosmic accidents. If the universe had been otherwise, we would not be here to ask. Our minds are entangled with the fabric of the cosmos. Our thoughts, the outcome of a chain that stretches back to the first moment. To ask why there is something rather than nothing is, in a sense, to ask why we are here rather than absent. It is the most intimate of questions, disguised as the most abstract. And so, once more, the silence of the void surrounds us. Did nothing exist before the universe, or is nothing not an option at all? Are we witnessing the outcome of a quantum fluctuation, a mathematical necessity, an eternal cycle, or something that defies every category we have invented? Each possibility is vast, terrifying, beautiful.
Each points beyond the horizon of what we know, into a darkness that may never yield a final answer.
The more we contemplate this abyss, the more the concept of before itself seems to dissolve. For time, which appears so steady in our lives, may be no more than a feature of our universe, like gravity or light. If so, then asking what came before the Big Bang may be like asking what lies beyond the edge of a shadow. It is not that something is there, but that the framework of the question misleads us. Yet this realization, rather than closing the matter, opens it wider. If time itself was born with the universe, then what does it mean for anything to begin? What does it mean for existence itself to unfold? Consider how Einstein revolutionized our view of reality. Space and time, once thought to be immutable, separate absolutes, became interwoven as space-time, malleable, curved, and dynamic. This fabric can stretch, ripple, bend under mass and energy. What once seemed eternal and fixed was revealed as contingent and mutable. Might our concept of nothingness undergo a similar transformation? Perhaps nothing is not the opposite of something, but another mode of being, misunderstood because we cling to categories drawn from human life. Quantum physics forces this upon us again and again. In the strange laboratory of the subatomic, particles exist in states of probability, neither here nor there until observed. The vacuum itself is a seething sea, restless with ephemeral particles. To us, this appears paradoxical. A vacuum is not empty, yet it is still called nothing. What then is the true nature of emptiness? Is it absence, or is it possibility? Philosophers wrestle with this as deeply as scientists. Martin Heidegger once declared that the fundamental question of metaphysics is, why are there beings at all, and not rather nothing? He called nothingness the most radical negation, a presence that haunts existence. For Heidegger, to encounter nothing is not to confront absence, but to feel the strangeness of being itself, the uncanny realization that everything we see could just as well not have been. Science, too, now inhabits this uncanny space. The Big Bang, the multiverse, quantum cosmology, all point not toward simple answers, but toward a deepening sense of mystery. And yet, even as the mystery grows, so too does our power to explore it. Our telescopes peer across billions of light years, capturing light that began its journey when the first stars ignited. We measure the cosmic microwave background with exquisite precision, mapping tiny fluctuations that foreshadowed galaxies. We detect gravitational waves, ripples in space-time itself, echoes of cataclysms in the deep past. Each discovery brings us closer to the edge of the beginning, closer to the threshold where the universe itself first surged into being. But none of these tools can peer past that ultimate horizon. The first fractions of a second remain opaque, hidden behind walls of physics we do not yet possess. To see beyond requires theories still in their infancy: quantum gravity, string theory, holography. Each offers tantalizing glimpses, like shards of a puzzle scattered across a floor, but the full picture eludes us. Was there truly nothing before the Big Bang? Was our universe born from collapse and rebirth? From brains colliding in higher dimensions? From fluctuations in a timeless quantum state? Each hypothesis is an attempt to name the unnameable. And as we struggle with these abstractions, the human element remains. We are, after all, beings who tell stories, who search for origins. For millennia, we have explained the cosmos in terms of divine creation, eternal cycles, or primordial chaos. Science continues this tradition, though with different tools, different language. It is not myth, but mathematics, not ritual, but experiment. Yet the drive is the same: to make sense of existence, to find our place in the incomprehensible vastness. There is a poetic irony here. The very beings who ponder nothingness are themselves temporary, finite, fragile. We live for a flicker of cosmic time on a small planet circling an ordinary star, and yet in that flicker, we dare to ask about the eternity that came before and the void that might follow. The question of nothing is not only about the universe, it is about us, about our capacity to imagine absence, to be haunted by the possibility of non-being. And in this haunting lies the true drama. For if there was nothing before the universe, then our existence is a miracle beyond comprehension. From sheer absence, all being arose. If instead there was always something, if reality in some form is eternal, then our lives are chapters in an endless book, moments in a story without beginning or end. Both visions are staggering, each in its own way, stripping us of the comfort of certainty. Science will continue its pursuit, tracing the cosmos with equations, peering deeper with instruments, reaching further with imagination. But perhaps the question of nothing will never be fully answered. Perhaps it is a question that defines the limits of thought itself, always a horizon just beyond our grasp. And yet to approach that horizon is itself meaningful, for it reminds us that we live not in a mundane world of givens, but in a reality that is strange, fragile, wondrous. And so as we gaze into the night sky, filled with galaxies beyond number, we are left with a double vision. We see something, the luminous splendor of existence, and we sense just beyond it the shadow of nothing, the silence from which it may have risen, or against which it eternally stands. This is the paradox we inhabit, beings of something, haunted by nothing.
If nothingness is the ultimate riddle, then entropy may be its shadow. For even within a universe brimming with stars and galaxies, there is the ever-present pull toward disorder, toward equilibrium, toward the fading of structure into uniform stillness. The second law of thermodynamics declares that entropy always increases, that energy spreads, that systems decay toward randomness. In this inexorable drift, we glimpse a kind of cosmic erosion, a slow march that, if carried to its end, suggests a future not of something, but of almost nothing. Imagine the far distant future, trillions upon trillions of years from now. The stars will have burned out, galaxies will have thinned, their brilliance extinguished. Black holes themselves will evaporate, leaking radiation until even they vanish. What remains is a vast, dark expanse, a thin soup of particles spread across immeasurable distances, nearly indistinguishable from nothing. This heat death of the universe is not absolute nothingness, but it is as close as nature may ever drift, a cosmos stripped of structure, purpose, and light. In contemplating this end, we sense how fragile existence truly is, how tenuous the flame of being against the cold pull of entropy. But here, too, lies paradox. For if the universe tends inexorably toward disorder, how did it begin in such extraordinary order? The cosmic microwave background shows us a universe that was astonishingly uniform, smoothed to 1 part in 100,000. This low entropy state is one of the deepest mysteries of cosmology. Why should the universe begin in such delicate simplicity? Why should something so ordered arise rather than nothing, or at least rather than the high entropy chaos we might expect? Some argue that this is evidence of deeper laws. Others that it points again to cycles, bounces, or multiverses, where improbable states inevitably occur somewhere. But the question remains, why this beginning, this improbable spark of order that allowed everything else to follow? The link between entropy and nothingness is profound. For if the ultimate fate of the cosmos is to dissolve into featureless equilibrium, then nothingness is not only a question of the past, but of the future. Perhaps the universe emerged from a state we call nothing, and perhaps it will return to one, though of a different kind, a thin, stretched emptiness, quiet and endless. The arrow of time, driven by entropy, ensures that nothing haunts both ends of the cosmic story. And yet, not all scientists accept this as destiny. Some models suggest that the universe may not drift into eternal darkness, but collapse back upon itself in a big crunch, or oscillate in endless cycles. Others envision the dominance of dark energy, leading to a big rip, where galaxies, stars, even atoms are torn apart by accelerated expansion. Each scenario reshapes the meaning of nothingness, as death, as rebirth, as transformation. Whether the future is silence or renewal, the specter of nothing remains at its heart. But here we must pause, for even as science sketches these vast futures, it also reminds us of scale. The universe has already existed for nearly 14 billion years. Stars will burn for trillions more. Black holes may last 100 quintillion years. Against such scales, our lives are brief flickers. And yet, within those flickers, we ask the question of nothingness. A question that transcends even the cosmic future. We, fragile beings of dust, dare to look backward to the origins of time and forward to its possible ends. We are witnesses to the story of something, poised between the mysteries of nothing on both sides. Perhaps that is the true significance of the question. To ask about nothing is to confront our own impermanence, for death itself is a kind of nothingness, the absence of thought, of self, of experience. We fear it, we resist it, and yet it mirrors the larger cosmic silence. When we ask if nothing existed before the universe, we are also asking, will there be nothing after us? Is the void behind us, or ahead, or both? The personal and the cosmic intertwine, for we cannot separate our own mortality from the mortality of stars. And still the mystery deepens. If entropy guarantees eventual dissolution, then why is there beauty now? Why is there order, structure, life? The answer lies in the dance between order and chaos, between expansion and collapse, between energy and form. Nothingness may be the default, but within it arise islands of something, stars igniting from clouds of gas, planets forming from dust, life stirring on a fragile rock. Against the pull of entropy, there is the countercurrent of creation, brief but luminous. This tension may be the essence of existence, the constant emergence of something from nothing, again and again, on every scale. And perhaps that is the secret hidden in the night sky. When we look up, we see galaxies scattered across the dark. Yet the dark is greater than the light, the emptiness vaster than the stars. The cosmos is mostly nothing, yet it is punctuated by brilliance. We are beings of the brilliance, asking questions from within the void. Our very existence is testimony to the strange fecundity of nothingness, the fact that even a universe tending toward emptiness can, for a time, teem with light, thought, and wonder. So the riddle persists. Nothing is the backdrop against which something shines. Whether before the Big Bang or after the last black hole evaporates, whether in the vast voids between galaxies or in the silence of our own deaths, nothingness haunts us. And in that haunting lies both terror and beauty. Terror because we glimpse the fragility of being. Beauty because it reminds us that every moment of existence is extraordinary, improbable, luminous against the shadow. The ancient philosophers who first pondered the void could never have imagined the modern tools we now wield: satellites mapping the earliest light of the cosmos, particle accelerators recreating conditions of the young universe, equations that stretch imagination itself to the breaking point.
And yet, the essence of their question remains unchanged. To them, nothing was not merely an absence, but a stage for speculation, a thought experiment to probe the boundaries of reason. Today, we cloak the same mystery in the language of quantum fields, inflation, and cosmological constants, but the haunting silence beneath remains the same. In Greek thought, chaos was the primal nothing, the yawning gap from which the ordered cosmos emerged. Yet chaos was never truly empty. It was a fertile void, a womb of potential. In Hindu cosmology, the cycles of creation and dissolution arise from a boundless ocean, again an emptiness pregnant with possibility. In Taoist thought, the Tao gives rise to the 10,000 things, but the Tao itself is a kind of nameless source beyond being and non-being. Across cultures, the void is never sterile. It is always the hidden wellspring of form. Could it be that science, in its own way, has arrived at the same conclusion, that nothing is never truly nothing? Modern physics suggests exactly that. The vacuum is restless, charged with zero-point energy. Quantum fluctuations seed universes. Fields drive inflation. Space-time itself may be emergent from deeper structures. The closer we come to nothing, the more something appears. It is as though the void resists our attempts to strip it bare, revealing hidden depths each time we push further. We reach for absence and we find structure. We search for silence and we uncover whispers. This resistance has led some to suggest that perhaps nothingness is not possible at all. To imagine nothing is to imagine absence of space, time, energy, law, possibility itself. But how can we imagine the absence of imagination? How can we conceive a state where no concept, no distinction, no reality exists? Perhaps the very act of conceiving nothing guarantees that it cannot exist, for in our thought it already becomes something. In this sense, the question of whether nothing existed before the universe may be unanswerable, not because science has not yet solved it, but because it is incoherent at its core. And yet the power of the question lies not in its answer, but in its challenge. To ask it forces us to recognize the strangeness of being, the improbability of existence, the mystery of laws and constants that could have been otherwise. It reminds us that the universe, for all its vastness, is not ordinary but miraculous. That miracle requires no supernatural explanation. It is a miracle of physics, of possibility, of the simple fact that anything exists at all. Still, many scientists are not content with philosophical gestures. They seek testable clues, hints written into the structure of the cosmos itself. Could the cosmic microwave background contain imprints of a prior universe? Scars from a bounce or a collision? Could subtle patterns in gravitational waves whisper of a deeper origin? Could the value of the cosmological constant, so small and yet so consequential, be evidence of a multiverse where countless other values exist? Each of these avenues is pursued not only with mathematics, but with instruments, detectors, satellites. The pursuit of nothing is paradoxically the pursuit of data. And yet there is humility in this effort. For the universe may not reveal its deepest secrets to us. The boundary of the Big Bang may be a veil we cannot pierce, no matter how powerful our telescopes. The early moments may remain hidden behind walls of energy and opacity, inaccessible to observation. If so, then the question of nothingness will remain forever speculative, a frontier not of measurement, but of thought. But is that not fitting? For nothingness, by definition, cannot be seen. It leaves no trace, no evidence. It is absence, not presence. To search for it in data may be a category mistake, like listening for silence with a microphone. Perhaps the true work of science here is not to find nothing, but to refine our understanding of something, to trace its contours so carefully that we glimpse the outlines of the void it excludes. Meanwhile, we are left with metaphors. We speak of the universe as a bubble expanding into nothing, though we know there is no outside. We speak of fluctuations in a vacuum, though we know the vacuum is a seething sea. We speak of time beginning, though we know beginnings presuppose time. Our language is stretched thin, always threatening to break under the weight of paradox. And yet, through these metaphors, we approach something profound, a recognition that the universe is stranger than words, that reality transcends the categories we have inherited. And perhaps that is the true gift of the question of nothing. It reminds us that science is not only a catalog of facts, but a journey into wonder. To confront the possibility of nothing is to feel the fragility of existence, to recognize that all we know could have been otherwise, or not at all. It is to sense the abyss that haunts the edges of being, and to marvel that we stand here, conscious, gazing into it. In this sense, nothing is not only a scientific problem, but an existential mirror. It reflects our own vulnerability, our mortality, our finite presence in an infinite cosmos. It confronts us with the possibility that our lives, like the universe itself, may be bracketed by nothingness, an absence before birth, an absence after death. And yet in between, there is something. That something is us, alive, aware, asking questions no other creatures on Earth have dared to ask. If the void is elusive, then the universe is a defiant answer to it. Everywhere we look, there is structure. Galaxies swirling like cosmic whirlpools, stars igniting with furious light, planets orbiting in delicate balance. Even in the great dark gulfs between galaxies, there are filaments of matter stretching like veins across unimaginable distances. The universe is not only something, it is an abundance of somethings, layered and intricate, a tapestry woven from the simplest of threads. How strange, then, that such complexity could arise from what some describe as nothing. One way to confront this strangeness is through the lens of emergence. In nature, complexity often arises from simplicity, from rules so basic they seem trivial. Snowflakes, with their dazzling symmetry, emerge from the simple laws of crystallization. Life itself, with all its diversity, arises from the replication and variation of molecules. Might the universe itself be an emergent phenomenon, arising inevitably from laws as simple as they are profound? If so, then nothing may be less a precondition than an illusion born of our limited view. Perhaps existence was bound to happen, as inevitable as frost forming on a window pane. But emergence does not answer the deeper question: why should there be laws at all? Why should mathematics have the power to summon stars from void? Eugene Wigner once called this the unreasonable effectiveness of mathematics, the mystery of why numbers and equations devised by human minds can so perfectly describe the workings of the cosmos. If the universe is mathematics, as Tegmark proposes, then perhaps laws are not imposed upon reality, but are reality. Yet again, we are caught in paradox. Mathematics feels eternal, necessary, independent of minds or matter, and yet it is only through minds that we glimpse it. This is where cosmology brushes against philosophy in its most daring forms. Some philosophers argue that nothingness is incoherent because existence itself is a logical necessity. If there can be nothing, then nothing would remain. But because something exists, it must have always been possible, perhaps even inevitable. Others suggest that we are caught in anthropic selection. We ask these questions only because we inhabit a universe where asking is possible. Out of countless possible realities or multiverses, only those with conscious observers can reflect upon their own origins. In this view, the very act of asking why there is something betrays the fact that only a something could ask. The anthropic principle is both profound and unsettling. It tells us that our universe may not be uniquely designed or inevitable, but one among many, its properties explained not by necessity but by selection. We find ourselves in a universe where life is possible, because in universes where life is not possible, there are no minds to ask the question. Some find this deeply unsatisfying, even evasive. Others see it as a natural extension of Darwin's insight into biology. Just as species are shaped by selection, so too might universes be shaped by the possibility of observers. Yet, even if the anthropic principle is true, it does not dispel the specter of nothingness. For if universes can exist in countless variations, what underlies them all? What framework permits their existence? Why should there be a multiverse at all, rather than no reality whatsoever? In this sense, the principle solves only part of the puzzle. The deeper enigma remains untouched. And still, as fragile creatures on a small planet, we dare to press on. We build machines to peer into the past, to capture faint whispers of the universe's birth. The James Webb Space Telescope peers deeper into time than any instrument before it, capturing light from the first galaxies. Experiments in particle physics probe the structure of matter at energies approaching those of the early cosmos. Each discovery is a fragment of the story, a piece of the puzzle of something and nothing. But the puzzle is not merely scientific, it is also poetic, existential, spiritual. For to ponder nothingness is to feel the thinness of our own existence. We live suspended between two apparent voids, the nothing before birth and the nothing after death. We cannot remember the first, we cannot experience the second, and so both haunt us with silence. Yet within that silence lies the brief miracle of life, of consciousness, of asking. Perhaps the most extraordinary thing is not that there is something, rather than nothing, but that the something has given rise to beings who wonder about it. This is why the question will never fade. It is not only about the cosmos, but about us. We long to know whether we are part of an eternal story or a fleeting spark in the void. We long to know whether our universe was born of necessity, chance, or miracle. And we long to know whether the nothingness we fear is truly empty, or if even there lies hidden potential waiting to give rise to new worlds. In this way, science and philosophy converge. Both strive not merely to catalog facts, but to touch the ineffable, to brush against the limits of thought. The physicist and the mystic, the philosopher and the poet, all stand beneath the same night sky, staring into the same darkness, feeling the same pull of the void. The words differ, the methods diverge, but the silence they confront is the same. And perhaps that silence is the answer, not because it explains, but because it reminds us that not everything can be explained, that there are questions which stretch beyond reason, which can only be lived, not solved, that nothingness, whether before the universe or after, is less a fact to be discovered than a mystery to be endured. And in enduring it, we discover the value of something, of stars, of thought, of life itself. In the end, every attempt to speak of nothing seems to reveal more about ourselves than about the void itself. We are creatures of meaning, forever seeking causes, contexts, explanations. To us, a beginning without a cause feels intolerable, a cosmos without origin unthinkable. And yet, nature may not share our discomfort. The universe may not require an answer that satisfies human intuition. It may simply be indifferent to our longing for why. Still, we press forward.
For the history of science is also the history of overturned impossibilities. Once the Earth seemed fixed and central, until Copernicus shifted it from the cosmic throne. Once the stars seemed eternal, until astrophysics revealed their births and deaths. Once space seemed an empty stage, until Einstein showed that the stage itself bends and flows. Perhaps in time, nothingness, too, will be redefined, not as absence, but as a phase, a condition with properties we cannot yet imagine. Already, hints of such redefinition appear in theories that dare to peek behind the curtain of the Big Bang. Some propose that the universe was born from a quantum tunneling event, leaping from nothing into existence as a particle leaps from one state to another. Others suggest that space-time itself may be holographic, an illusion projected from deeper, timeless physics. In these views, nothingness is not annihilation, but transition, not emptiness, but the hidden reservoir of all possible being. And if this is true, then the line between nothing and something may not be sharp but porous, blurred like dawn between night and day. Perhaps there was never a moment when nothing reigned, only states we mislabel because we lack the language to describe them. Just as empty space conceals fields and forces, so too might nothing conceal the seedbed of universes, the silent loom from which existence is woven. This idea is dizzying, but it is not without precedent. Again and again, the cosmos has revealed layers beneath layers, depths beneath depths. Atoms were once thought indivisible until electrons, protons, neutrons appeared. Protons and neutrons dissolved into quarks, which in turn may be knots of vibrating strings. Every foundation has given way to deeper structure. Should we be surprised if the foundation of nothingness itself turns out to be another form of something? And yet, there is another possibility, more radical still, that the question itself is flawed. To ask what existed before the universe may be as misguided as asking what lies north of the North Pole. The very idea of before presupposes time, and if time began with the universe, then the question unravels. Perhaps the silence we encounter when we push beyond the Big Bang is not the silence of nothing, but the silence of language breaking against reality. In this case, nothingness may not exist, not because there is something in its place, but because the category itself dissolves. Still, even if the question is flawed, its persistence is revealing. It shows that we cannot help but seek grounding, that our minds recoil from uncaused beginnings, that we yearn for explanation even when none may be possible. And perhaps this yearning itself is significant, for in it lies the essence of what it means to be human, to confront mystery not with resignation but with curiosity, to build stories, models, theories that stretch into the dark. This curiosity has carried us far. It has led us to discover the cosmic microwave background, to decode the expansion of space, to glimpse the first galaxies. It has given us tools to measure the faint hiss of creation itself, to weigh the universe, to predict its possible fates. And yet, at the edge of these achievements, we confront once more the abyss of nothing. The further we travel, the more profound the silence becomes. But perhaps the silence is not empty after all. Perhaps it is the background against which existence gains meaning, the contrast that makes being perceptible. Just as silence makes music possible, so too might nothing make something meaningful. Without the possibility of nothing, we might never recognize the wonder of being. Without the threat of emptiness, we might never cherish the fragile spark of life. In this sense, nothingness may be less an absence than a companion, shadowing existence, giving it weight. It is here that the scientific and the existential meet. For the void we contemplate in cosmology mirrors the void we contemplate in ourselves. Death, the end of consciousness, is our personal version of cosmic nothingness. Just as we ask what existed before the universe, we ask what awaits us after life. And in both cases, the answers evade us, slipping always into silence. Yet the asking changes us. To live with the awareness of nothing is to live more intensely, to recognize the miracle of each moment of something. The stars remind us of this truth. Their light travels across eons of darkness, pinpricks in a sea of void. They shine because they burn, and they burn because the universe is structured just so, with laws and constants finely balanced. Without that balance, there would be no stars, no planets, no life. And so whenever we look at the night sky, we are looking not only at something, but at the triumph of something over nothing, however temporary it may be.
The night sky, for all its beauty, is mostly darkness. Between the galaxies lie gulfs so vast that light may take billions of years to cross them. In those gulfs, there are no stars, no warmth, no life, only the thin whisper of particles and the faint pressure of dark energy, stretching space apart. This is the true face of the cosmos, a near emptiness punctuated by rare brilliance. To us, bound to a world rich with air and oceans, forests and cities, the scale of this emptiness is almost unbearable. And yet, it is against this backdrop that life has emerged, that thought has arisen, that we ask the question of nothing. For all its silence, the void is not passive. It shapes the architecture of the universe itself. The great webs of galaxies form not in defiance of emptiness, but because of it, collapsing under gravity in a sea of expanding space. Stars ignite because matter gathers in patches surrounded by vast vacuums that press them into being. Even the atoms in our bodies are forged in the deaths of stars, born in bursts of energy that contrasted with the silence around them. Emptiness and existence are not enemies, but partners in a cosmic dance. And this partnership is written in the laws of physics themselves. Quantum mechanics shows us that fluctuations in emptiness can give rise to particles, energy, even entire universes. General relativity shows us that empty space has structure, curvature, dynamism. Far from being nothing, the void is active, restless, creative. It is the soil from which galaxies bloom, the stage upon which the drama of matter unfolds. Perhaps then the very word nothing is misleading. What we call nothing is, in truth, a subtle kind of something, invisible yet essential. Still, the human mind yearns for absolutes. We do not want a nothing that is secretly something. We want to know whether true absence is possible at all. Could there have been no laws, no space, no time, no possibility? Or is such a notion incoherent, like a color beyond sight? Some argue that absolute nothing cannot exist, because even to imagine it is to bring it into thought, to transform it into something. Others argue that absolute nothing is the default, and that existence requires explanation. Between these poles lies the tension that has driven philosophy and physics alike. Is being necessary or contingent? Consider again the enigma of fine-tuning. The universe as we know it depends on values balanced with exquisite precision. The strength of the strong nuclear force, the mass of the electron, the rate of cosmic expansion. Change them slightly and stars would never form,
chemistry would never ignite, life would never stir. Some see in this fine-tuning the suggestion of deeper necessity, as though the universe could not have been otherwise. Others invoke the multiverse, where countless universes exist with different constants, and we find ourselves in one suited for life simply because we could not exist elsewhere. But both answers lead us back to the same abyss. Why is there a multiverse at all, or necessity, or law? Why not nothing? And perhaps this is the heart of the mystery. Nothing is not a scientific concept, but a horizon of thought. It is the shadow that falls at the edge of explanation, the silence that waits beyond the reach of mathematics. We can describe how the universe evolves, how galaxies form, how life emerges. We can even speculate how the universe may have begun, through fluctuations, cycles, or collisions. But when we ask why there is something rather than nothing, we reach a place where reason falters. The question is not within science alone. It is at the root of existence itself. This recognition does not diminish science, it elevates it. For the pursuit of answers, even if the ultimate question remains unanswerable, is itself an act of meaning. Each observation, each theory, each attempt to describe the void enriches our understanding of what it means to be. Even if nothing is never found, the search reveals everything. And in that sense, the question of nothing may be less about resolution than about awakening. A reminder that reality is not ordinary, that existence is fragile, improbable, miraculous. And so, standing beneath the stars, we sense both sides of the paradox. The cosmos is overwhelmingly empty, and yet it is full of light. Nothingness haunts us, and yet existence abounds. The universe may dissolve into silence, and yet for now it sings with galaxies and life. To live is to dwell in this paradox, to feel the weight of absence and the wonder of presence. Perhaps there was never absolute nothing. Perhaps there will never be. But even if nothingness is an illusion, it is an illusion that shapes us, drives us, defines our hunger for truth. And in that hunger, humanity has built its identity. For we are not content to live without asking. We must know, we must wonder, we must stretch thought to its limits. And though the void may remain silent, our questions fill it with meaning. If nothing existed before the universe, then our existence is a miracle beyond all comprehension. If nothing never existed, then we are part of an eternal reality that flows without beginning or end. Either way, the night sky above us whispers of mystery, and the mystery itself is enough to sustain wonder. Yet even as we stand humbled by the mystery of origins, the universe reminds us that it is not only a story of beginnings, but of journeys. To ask whether nothing existed before the cosmos is also to ask where that cosmos is headed and what role we play within it. For if nothingness haunts the past, it also haunts the future. The same laws that govern galaxies also govern destinies, shaping the long arc of existence from birth to eventual fate. The universe, as far as we can tell, is expanding faster and faster, driven by the enigmatic force of dark energy. If this acceleration continues, galaxies will drift beyond sight, their light forever out of reach. In 100 billion years, future observers in some distant galaxy may see nothing but their own island of stars, unaware that the universe ever held more. On that scale, our present age is privileged. We live at a time when the cosmos still reveals its grandeur, when the tapestry of galaxies is spread before us like a map. One day that map will fade into darkness, and the universe will look far emptier than it does now. This projected loneliness is itself a form of nothingness, the gradual erasure of cosmic memory. Structures will dissolve,
lights will fade, and the void will reclaim what is now ablaze with stars. Against this backdrop, the question of why there is something rather than nothing becomes not only philosophical, but urgent. For if existence is fragile, if the cosmos is moving towards silence, then what we do with our moment of light acquires profound significance. Earth itself is a testament to this fleeting brightness. From a cloud of dust and gas orbiting a newborn star, our planet coalesced, cooled, and nurtured life. Over billions of years, life evolved into creatures capable of reflection, language, imagination. We are part of the cosmos's brief flowering, atoms forged in ancient stars, now pondering the fate of stars to come. Our questions about nothingness are not idle. They are the natural consequence of a universe that has produced beings capable of asking them. And those questions connect the cosmic to the personal. Just as we wonder whether the universe emerged from nothing, we wonder whether our own consciousness will dissolve into nothingness when we die. The symmetry is striking. The silence before birth, the silence after death, both bookending the fragile span of awareness. We do not remember the first, we cannot imagine the second, and so we project them onto the cosmos itself. To ask whether there was nothing before the universe is in some sense to ask whether death is the end or a transformation. Cosmology and mortality are mirrors of each other, each reflecting the same abyss. And yet, in both cases, there is also wonder. For even if death returns us to silence, we were here for a time, awake in the vastness. Even if the universe emerged from nothing, it emerged into something magnificent. Galaxies, stars, life, thought. The fact that we can contemplate nothingness is itself extraordinary, a sign that existence has reached a level of self-awareness. Through us, the universe reflects on its own origins, asking questions that no empty void could ever ask. This awareness brings with it responsibility, for we now understand that Earth is fragile, that our civilization is but one thread in a precarious web. The universe may be indifferent to our fate, but we are not. If the universe tends toward nothingness, then our task is to make the most of the something we have, to preserve life, to explore the stars, to carry meaning into the silence. Perhaps we cannot solve the riddle of nothing, but we can live in defiance of it, filling our brief span with creation rather than despair. Indeed, this is what science itself represents, a rebellion against nothing. Each equation, each telescope, each experiment is a way of carving light into the void. The act of understanding is itself an affirmation of being, a refusal to accept absence as the final word. When we chart the stars, when we uncover the laws of nature, when we peer into the origins of time, we are declaring that something matters, that existence is not only real, but worthy of comprehension. And so, as we approach the final chapters of this journey, we find that the question of nothing is not merely about the universe's birth, but its meaning. Did nothing exist before the universe? Perhaps. Or perhaps nothing never existed at all. But what matters most is that now, in this brief window of cosmic history, there is something. And within that something, there is us. If nothingness was the shadow at the universe's birth, it is also the horizon toward which our world drifts. For Earth, like all things, is transient. Our planet circles a middle-aged star, burning steadily but not forever. In 5 billion years, the Sun will swell into a red giant, consuming Mercury and Venus, boiling Earth's oceans, searing its surface. Whatever life remains will be driven to extinction, swallowed by the inevitability of stellar death. The story of our planet is a story with an ending, written into the physics of stars themselves. And beyond that lies deeper silence. Long after Earth is gone, long after the sun has burned out, the galaxy itself will fade. Stars will exhaust their fuel, leaving only white dwarfs, neutron stars, and black holes. Over incomprehensible spans of time, even these remnants will decay. The universe will darken, drift, cool. It will approach a state that resembles nothing, not absolute nothing, but a near emptiness where structure no longer exists, where time itself loses meaning in the monotony of equilibrium. This vision, called the heat death, is perhaps the closest science can come to imagining nothing as destiny. But humanity need not surrender to this vision passively, for we are not merely passengers on a doomed world. We are thinkers, builders, explorers. Already we have left footprints on the moon, sent probes to the outer planets, launched messages into interstellar space. These are small steps, fragile and tentative, but they are declarations that we will not accept nothingness without resistance, that we will carry our spark as far as we can. Perhaps in the distant future, humanity, or its descendants, whether biological or machine, will find ways to endure beyond Earth, beyond the sun, beyond the galaxy itself. Perhaps intelligence will scatter across the stars, seeding new worlds with thought, carrying memory into the long twilight of the cosmos. If so, then we will have extended the triumph of something against the pole of nothing, prolonging the miracle of awareness. And yet, even if our efforts fail, even if life perishes with Earth, the fact remains that we were here, that the universe, for a time, produced beings who could imagine their own extinction, who could ponder the void from which they came and into which they may vanish. This is no small thing. It is, perhaps, the universe's way of knowing itself. In us, something has turned to face nothing and asked it questions it cannot answer. This confrontation may be the ultimate meaning of science, philosophy, even art, to wrestle with the silence, to inscribe our voices against it, however briefly. Every discovery, every creation, every act of wonder is a refusal to let nothing have the last word. And though the cosmos may end in emptiness, the fact that it once blazed with galaxies, with stars, with life, ensures that nothing will never erase the fact of something. Existence has happened. That cannot be undone. In this way, we may reconcile ourselves to the abyss. Nothingness may haunt us, but it also frames our significance. Just as darkness makes stars shine, so does nothing make being precious. Each heartbeat, each thought, each moment is luminous against the backdrop of non-existence. Perhaps the deepest lesson of cosmology is not what preceded the universe, but what it means that the universe exists now. For here we are, on a small world orbiting an ordinary star, and a galaxy among billions. And yet from this humble vantage, we have glimpsed the origin of time, measured the echo of creation, imagined the fate of all things. We have asked whether nothing once was, and in asking, we have filled that nothing with meaning.
So at last we return to the question that has guided us. Did nothing exist before the universe? After all the theories, all the models, all the speculation, the answer remains uncertain, perhaps unreachable. Maybe there was a quantum fluctuation, a timeless wave function, a cosmic bounce. Maybe the universe is one bubble among infinite others. Maybe time itself began with the Big Bang, making before a word with no meaning. Or maybe, most haunting of all, there was truly nothing, an absence so absolute that its transformation into being is the greatest mystery of all. Yet the lack of a final answer does not diminish the power of the question. On the contrary, it amplifies it. For what the question reveals is not only the limits of our knowledge, but the depth of our wonder. To ask about nothing is to confront the strangeness of being,
to recognize that existence is not inevitable, but miraculous, fragile, contingent. It is to feel the weight of the void, and in doing so, to appreciate the brightness of the stars, the brief gift of life, the miracle of consciousness. In the silence before the Big Bang, whether real or imagined, we sense our own silence before birth. In the possible nothingness after the universe ends, we sense our own mortality. The cosmic and the personal mirror each other, each haunted by absence, each redeemed by presence. And in this mirroring, we find meaning. For if the universe began from nothing, then everything we see is a miracle of emergence. If it began from something eternal, then we are part of that eternity. Either way, our existence is extraordinary. Earth itself bears witness to this miracle. Against overwhelming odds, a small world of rock and water gave rise to forests, oceans, skies filled with birds, civilizations of thought and art. And from those civilizations arose the question of nothingness, the most abstract, the most impossible, yet the most human of all questions. To ask it is to stand at the intersection of science and philosophy, of physics and poetry. It is to declare that life is not content merely to survive, it must also wonder. And so, what should we do with the knowledge that nothing haunts us? We should live. We should create. We should explore. We should cherish the fragile moment of something that we inhabit. For if the cosmos is drifting toward silence, then our voices matter all the more. If our time is brief, then every heartbeat is infinite in value. If nothingness is inevitable, then our defiance of it, through love, through thought, through discovery, is the most meaningful act of all. Look once more at the night sky. The stars are ancient, yet their light reaches us now, a bridge across billions of years. Each photon is a messenger, a reminder that something exists, that being triumphs over absence. And as we gaze upward, we too become part of that triumph, part of the story that nothing could not erase. So, did nothing exist before the universe? Perhaps. Or perhaps nothing never was. But what is certain is this: there is something now. And within that something, there is us, fragile, temporary, yet luminous. We are the cosmos awakened, asking its own questions, marveling at its own existence. And in that asking, in that marveling, nothingness is already defeated.